Welcome back, guys, and we continue our study for math method. Today, I'd like to talk about random variable for these videos. Again, this one is not required in 2020 study design, but before we go to the normal, I think it's essentially for you to understand what do we mean by continuous random variable. Okay. So first thing I want to emphasize here is continuous random variable is actually from discrete. Okay, it's taken from discrete random variables. And of course, the continuous random variable basically is cannot really countable. And for example, a person's weight in kilograms, and this one is actually implies that this person's weight is between some region, right? If it's 83, it implies that it's up to greater than 82.5 and less than 83.5 because we're always rounding up, right? So if we keep giving the decimal place, we will know precisely the weight, but essentially the overall weight will be infinite many decimals places, right? That's why we need to know that this one we can continuously keep going. So essentially for us, the exactly for equal to the particular value will be 0 because w cannot take an exact value, and it is will be true for all the random variables, right? So really in practice, we can make really appropriate interval to calculate the exactly probability, right? So from above, if we only take w0 equal to 83, actually we can calculate the probability between 82.5 to 83.5. Essentially means the area under the graph will give us the probability. Okay. So if we change this histogram to smaller, I mean like tiny, then we can make it as a smooth curve, and we call this smooth curve is probability density functions, and only the interval or the area under the curve will be our probabilities. Okay, so for any functions is defined as probability density functions or PDF. It must satisfy fx is always greater than or equal to 0, and the area under the curve must be equal to 1 as well, because it's need to above the x-axis. Otherwise, if it's lower the x-axis, when we do the anti-differentiation, we're gonna get the signed areas, right? So, but our probability can never be negative, okay? And this one, the probability density function of the random variables. So if we want to find the probability between A and B for some region, we have to do the anti-differentiation between A and B. And essentially the area is our probability, okay? So for any example, they want us to make sure its probability density functions. It essentially means the anti-differentiation must be equals to 1, and every single x values must be greater than 0. And if the question is ask us to sketch the graph for this part, x greater than 1 or x less than 0, we have to include this one to tell our probability or our x value can be negative infinity to positive infinity, right? Okay, cannot only draw from 0 to 1, done. No, we have to show the zeros as well. Okay, so after that, I also want to emphasize one point of how to write integral with infinity. So in such case, because our ex is unbounded, right? So our upper limit will be positive infinity. So in such case, because of this one, so if we integrate anything, we write the square brackets. The bottom and upper here must be taken by some numbers. Okay, essentially it means the positive infinity or negative infinity, they are just like sample, so they are not like the number. That's why we have to make it k over here, and we make the limit k approach to infinity. Either you can do this 0, k, and limit k approach negative infinity. Okay, that's just the way, we the notation we emphasize here. So it simply just means the square brackets for upper and lower boundary cannot take infinity. So that's why we use this trick to satisfy all the requirement or the notation requirement. Okay, let's keep going. So for this one, make sure you know how to type this thing. Okay. And the next one, again, conditional probability can combine with continuous random variable as well. Essentially, it's just like two anti-differentiation, and we calculate, then we do the algebra to get the values. Okay. So for continuous random variable, the one takeaway message is just remember to integrate, okay, over some certain interval to get the value. And as for the 15b, the mean and the median for continuous random variable, mean again for our discrete random variable, it's addition. But for the continuous random variable, it's just integration. But just remember you should times x in front of your density function. And for if this inside of expected value is not x, it's like x squared plus 1 or x cubed, you just make x cubed over here. Okay, again, you can calculate the expected value for that random variables. And next one I want to emphasize here is percentile and the median. So percentile just means like percentage, and the median just like exactly 50%. So if you above your class median mark, which means you are on the top 50%, and which means your mark is, I mean, overall you will be, sorry, overall like your mark is beyond 50%, or like your ranking is in the top half left. Okay, so for the median, it's essentially like cut our whole probability to half, 50% and 50%. So from negative infinity to m, you can get 50%, or from m to positive infinity, you can get 50% as well. This is for m. And for 15c, the only takeaway message is for measure the spread, you have to use variance or like the standard deviation. The formula we use is exactly the same, so we use ex squared minus the ex squared whole thing to get the variance. Okay, for standard deviation, just square root of the variance x. Okay, and again, you're gonna see this one. This one we will discuss later in the next chapter once we introduce what do we mean by the normal distribution. Okay, so the last one is again can link to our further math. It's interquartile range, but this one is not that important in math method. The interquartile range basically is Q3 minus Q1, and Q3 is just means like 75% of percentile, so which is top 25%, and the 25 percentile, which is refers to Q1, which like the bottom 25%. Okay, so if I make 0 to 100%, my Q1 is over here, 25. My M is over here to overall 50%, and my Q3 is over here. So overall, sorry, it's overall over here is 75%. Okay, here is 75%. That's the and interquartile range is just Q3 minus Q1. Okay. So for the 15D, the properties of mean and variance you do need to know, and you can just, if you have interest in this one, you can look at this one. Otherwise, you just can leave it. And also for the 15E, the cumulative distribution function is just give us a name of the integration after the density function. Okay, that's why we call it CDF. Okay, CDF basically just the probabilities, and it's the integration of our density functions. Okay, so for the 15, the takeaway message here is just remember, if you want to find the probability in for continuous random variable, do use integration, okay, to find the area. Okay, hopefully my video is clarify your some doubts, and if you want to discuss more or you want to write any comment, please write below. And also thanks for watching, and please subscribe and click the like button, and I see you guys for the next videos. Bye bye.